Okay, first thing, this is your second assessment review for the second assessment on roots and radicals. Okay, we're going to be making some changes throughout the kind of packet here. So it says convert, by the way, get this out of here, this 2. Just find out what that equals. That's all I want. So the cube root of 15. 15 is not a perfect cube, so we take it on our calculator to the power of 1/3 to find out what times what times what is 15. 2.47. Okay, now multiplication. I'm going to do a favor. I'm going to put a couple of numbers here because we're going to make some changes. A 3 and a 4. Those are going to be our multipliers. And multiplying roots has 3 steps in the procedure. So I take 3 times 4 is 12. And then I put a cubed root. And then I take 5 times 75. Okay, so that was 375. Now I drop the 12. And I'm going to try to separate that into 2 different cubed roots. One of which needs to be a perfect cube for that to work out. So I'm on my cubes list. So 375 divided by 343 does not work. 375 divided by 216 does not work. 375 divided by 125 does work. So I put 125 and 3. Just be in that order. Now we get rid of this one, okay? Because the cube root of 125 is 5. And last, I take 12 times 5, and that's 60. So 60 cubed root 3. Okay, 2 cubed root of 5 plus just the cubed root of 40. Now, adding's different. You want to make a chart and write down each one of your add-ins. There's going to be 2 steps to simplify each, because we not only need the roots to be the same kind of root, we need the numbers inside them to be the same as well. So I drop my 2 times. Well, the thing is, I don't believe 5 divides by anything on the list of my perfect cubes, so that's just going to be what I stick with. Okay, now 40. There's no multiplier, so just 2 cubed roots is all we need. Okay, so 40, I believe 40 is divisible by 8, okay? So if I divide 40 by 8, the result's 5, so we always get rid of that one because it's equal to a whole number, 2. So 2 cubed root 5. Let's look at those 2. They're both cubed root with a 5, and we just add the 2 and the 2, and that's 4. Okay, simplifying with variables, you break it up. So the 500 has its own cubed root, the x to the 7th has its own, and the y to the 11th has its own. Okay, so 500, got to be a perfect cube. It's not going to divide by 343. Or 216. It might divide by 125, and it does. So 125, put that first. They're both cubed roots. And 4. Get rid of this because you know that the cubed root of 125 is 5. Okay, so 5 cubed root of 4. Now I group these. How many groups of 2 can you get out of 7? Well, I believe you can get 2. There'd be 1 left. How many groups of 3 can get 11? There'd be 3 with 2 left. So I make my root. The 5's out. The 4's in. The x squared's out. And the x is in. The y cube's out. The y squared's in. Okay, so it is a cubed root, so I need to put the little 3 inside of that. Okay, next up, let's solve some equations with roots. Circle your root. There's nothing outside of that root. So I can cube both sides. That cancels, and I can cube that side. So this side, I just have 5x minus 4. And 3 is just a simple power. So 2 to the third power, regular power, is 8. There's only one answer to that one. So you're like, why didn't you put that right away? Well, because I didn't know. Until the root's gone, I don't know how many answers there are. It's 12/5, or 2.4. Next one, circle your root. This time I got stuff outside that needs to go. I have a 7 being added, and then I have a multiplier of -2. So at first I minus 7. That's 8. So I have -2 times the square root of 2x plus 5. There's no number here, no little number. It's a square root. And now I divide by my multiplier. -4. Square root of 2x plus 5. Okay? Now I can take both sides to the second. Out, and that's 2x plus 5 on that side. On the other side, if you wrote -4 to the second, is going to be 16. One answer is all I have. So minus 5, so 2x equals 11. So it's going to be 11 over 2. Okay, let's go look for some other roots. Well, there's no, oh, there we go. Okay. Nothing outside, so I'm ready to do both sides to the second power because it's a square root. This side I have 9x. This side I don't know what I have. I need to go over here and duplicate and foil that side. So x times x, x times -10, -10 times x, and -10 times -10. X squared, -10x, -10x, and positive 100. So it's going to be x squared minus 20x plus 100. At this point, I can see there's two answers. And at this point, I can see I'm going to have to factor. So I need to move the 9x so the equation is equal to 0. It's minus 29x plus 100, and it's a 3-term factoring. So GCF, and then the T. GCF, there is none. 1 times positive 100 is positive 100, sum of 29. It's 4 and 25. And A is equal to 1 here. So it's 1x squared, so it's x, and then 4 and 25. So I got minus 29 minus 4. So x minus 4 equals 0, x minus 25 equals 0. So I get 4 and 25. Okay, now I get some problems that are not roots. X to the third's all I have. Not in parentheses, and I don't need to factor, so just box it. Cancel the multiplier. 1080 divided by 5 is 216. And then I do the cubed root of both sides. It's an odd root, so no plus minus is needed. And I take 216, not to the third because it's a root. I reciprocate that power to 1/3, and that's 6. Out of here with those. Okay, next one. I think it's to the 5/3 power, so I'm maybe looking at 5. But since it's entire expression, I'm going to want to use my Q and my chart, kind of. So Q to the 5/3 power minus 73 equals 170. Plus 73 plus 73. Q to the 5/3 is 243. And then we reciprocate the power to 3/5. That's Q. Now remember, that's the power and that's the root. Okay? The root's odd, so I don't need the plus or minus, so I'm going to put no, don't need to do that side. 243 to the 3/5 power is 27. So what's really equal to 27 is my x minus 5. I get 32. Rationalize the expression, not the denominator. Denominator would have to have a fraction. You have a minus, so you need to make one with a plus, and then FOIL. That's how you rationalize. Rationalize means just get one number as the answer. So it's 25. Those cancel. That's negative 9 I to the second. So I to the second is negative 1 times negative 9 is 9. So 25 plus 9 is 34. 34 is the answer. Okay, next one. Switch your minus to plus. Put a 1, put a 1. And now it's foiling time. So 3 times 3. 3 times 1 square root 6, negative 1 square root 6 times 3, and negative 1 square root 6 times 1 square root 6. So it's 9. It's 3 square root 6. It's negative 3 square root 6. Those cancel. Negative 1 square root 36. Square root 36 is 6, though. It's going to be negative 6. So 9 and negative 6 add up to 3. Fun one here. Y equals 4 times the cubed root of x minus 3. Take the cubed root off. Let's just go with square root. So let's write a new equation. 4 square root of x without the minus 3, which will come back in. And I only want to pick perfect squares, so 1, 4, 9, and negative numbers aren't perfect squares, so stop there. You don't want to be putting negatives in there. Now you can take it to the 1/2 power. And minus 6, that's 6. Or you can put it in a square root, so 4 second. 4 minus 6, and that's going to be 2. So they go down by 4, so that would take me to negative 2 and negative 6. Now the minus 3, you got to add 3 to all your x's. So that's 12 plus 3 is 7, plus 3 is 4, plus 3 is 3. So 12. 2, 4, 6, 8, 10, 12, and then up 1, 2, 3, 4, 5, 6. Scratch that. Graph this one first. That's your last point before you stop. 1, 2, 3. Sorry, 2, 3, 1, 2, 3, 4, 5, 6. Stop. Can't go past that. 4, negative 2, 2, 4, 1, 2. 7, 2, 1, 2, 3, 4, 5, 6, or 2, 4, 6, 7. 1, 2, 2, 4, 6, 8, 10, 12. Okay, 1, 2, 3, 4, 5, 6. Okay, arrow only on that side.